Stoichiometry calculations with moles. The word stoichiometry is derived from two Greek words, stoichion, meaning element, and metron, meaning measure. The coefficients in a balanced equation give the ratio of moles of reactants to moles of products. So we read this as 2 moles of hydrogen plus 1 mole of oxygen yields 2 moles of H2O. The coefficients in front of the products and reactants can be used to create ratios to show how much of each product is needed for each reactant. For the formation of water, we have 2 moles of H2 is needed to react with every 1 mole of oxygen present. 2 moles of H2 would be required for every 2 moles of water formed, and 1 mole of oxygen is needed for every 2 moles of water formed. We're just matching up the coefficients there. The ratios above can be used to determine the quantity of any reactant or product. For example, for every 2 moles of H2 consumed, you will need 1 mole of oxygen to completely react with it, and 2 moles of water will be produced. Don't get confused by the subscripts. Hydrogen and oxygen are both diatomic. They are never found as single elements. Only the coefficients matter for these calculations, though. We can use the mole ratios to predict quantities involved in the reaction. So here's a question. How many moles of oxygen are needed to produce 8 moles of water? So start by writing your given, 8 moles of water. We're going to multiply by a ratio so that the moles of water cancels and becomes moles of oxygen. So we start with 8 moles of water, and in the numerator we put the moles of oxygen. That goes in because that's what we want to find. Then we put moles of water in the denominator so it will cancel out the given right over here. So here we go. Fill in the coefficients so that the moles of water cancels and becomes moles of oxygen. So here's our moles of oxygen from the balanced equation. Here's our moles of water. So we get 1 on top, 2 on the bottom. Then we do the simple math. We have 8 moles of water divided by 2 moles of water gives you 4. 4 times moles of oxygen is 4 moles of oxygen. And another problem, how many moles of hydrogen are needed to produce 7 moles of ammonia, NH3? We start with what we want to find, that's our given, 7 moles of ammonia. Then we have moles of hydrogen on top and then moles of ammonia on the bottom so we can cancel out moles of ammonia. So 2, multiply by a ratio. The units you want go in the numerator, the units of your given go in the denominator. So here's our 3 moles of hydrogen that goes on top. Here's the 2 moles of ammonia. And we fill in the coefficients from the balanced equation. That's what we just did. And let's see what we do next. So here's what we had from the previous slide. And the 2 moles of ammonia cancel with the 7 moles of ammonia. But we have 7 divided by 2, so that's what, 3.5. We multiply that by 3 moles of hydrogen, and we get 10.5 moles of H2. Notice it does not have to be an integer. So we've completed the multiplication. Check your units. And then the units of your given should always cancel with that of the denominator. And then here's your answer. 10.5 moles of hydrogen are needed to produce 7 moles of ammonia.